All right, so our third lecture is on applications, and I highly encourage you to read your books in this particular section because there's a lot of examples in there that that are very good, and we're going to follow the same model that's used as a problem-solving strategy in the textbook to solve similar problems. Okay, so what is the problem-solving strategy that's presented here? So the suggestion is to read the problem carefully and list knowns and unknowns. Sometimes you'll do this along with the second step, which is to assign a variable to one of the unknown quantities, and then you're going to rewrite the remaining quantities using that assigned variable. So you may have several unknowns, but once you fix one of them to some variable, say x, then you should be able to represent the other ones in terms of that x, and we'll see many examples like this. Then the third step is to find some kind of equation that best describes the situation using those variables that you've just assigned. And then you'll want to solve that equation. And then once you solve that equation, you want to rewrite your solution so that it answers the original question. So let's take a look at some examples. Okay, so in this first example here, we're told that the length of a rectangle is 1 foot more than twice the width. We're given some information about the perimeter. The perimeter is 20 feet, and we want to find the dimensions of the rectangle. So following our strategy up above, let's draw a picture first, and then we'll be able to assign some variables. Okay, so we got some rectangle here. Okay, and the length of a rectangle, which we'll just make it this length here, is 1 foot more than twice the width. So since we're told information about the length in terms of the width, I think it's a good idea to make the width your x variable. All right. Now, if you don't have a picture like this to draw on and introduce your variable there, you could just introduce it in words. You could say let x equal the width. But in this situation, a picture is going to be pretty helpful here. So we have our width, and then the length of the rectangle is 1 foot more than twice the width. So if we do 2x, that'll be twice the width, and one more would be to add 1. So this will be the length then. So 2x plus 1 will be the length of the rectangle, and the width is x. So now we have this nice picture, and we can now use the perimeter information to write out an equation. So we've assigned these variables, now let's write an equation. So the perimeter is 20 feet. So if the perimeter is 20, well, what is the perimeter? The perimeter is going to be the sum of all these lengths. So we have 2 of the x's, and we have 2 of these 2x plus 1's. And at this point, we have an equation that describes the situation, and let's try to solve for x, and we'll figure out the width, and then we can figure out the length. So we're just going to use the strategies that we've been using before. So we'll distribute this information over here. So we'll have to distribute in this 2. So we'll have 4x plus 2. And then we'll have 20 equals 6x plus 2. And then to isolate the x, we're going to have to subtract the 2 over. So subtract 2, we'll get 18 equals 6x. And then we'll have to divide both sides by 6 to get our width, which is 3. So the last step up above, which is to rewrite your solution as an answer to the original question, yes, we've solved for x, but remember the original question is to find the dimensions. So we should translate our answer into an actual answer. So the width is 3. So that's 3 feet. And the length is 2x plus 1. So if I substituted 3 into this, then we have 7, right? So 2 times 3 plus 1, so 7 feet. So we could consider this the answer. If you wanted to say the dimensions, you could say 3 feet by 7 feet also. So these are kind of two acceptable answers. All right. So let's take a look at this example here. So this example has to do with a store. Every item in this dollar store costs $1. When Mary opens the store, there's $125.50 in the cash register. When she counts the money at the end of the day, the total is $1,058.60. If the sales tax is 8.5%, how many items were sold that day? Okay, so following our strategy, at this point, what are the unknowns? What are we trying to figure out? Well, we're trying to figure out how many items were sold that day. So that's probably a good quantity to assign our x to. So let's say x is the number of items sold that day. To identify this, just look for what you're trying to find. At least look for the question mark. That should tell you there's something there that needs to be found. Okay, now let's, you're going to usually have to reread these a few times. So every item in the store is $1. So if I were to have X items, the cost would just be 1 times X. However, the sales tax, it says over here, is 8.5%. So what is the cost of an item taking into account the sales tax? Well, 8.5%, right, we can rewrite this as 0.085, right? Percentages we can rewrite like this. And, right, just divide by 100. Okay, or simpler ways just to move the decimal over 2, just to remember that. So what would the total cost be? Well, it would be 1 plus this, right? Because the sales tax on $1 would be, to multiply this. Okay, which would just be this. So then you would add them. So the cost per item would be 1.085x. So that would be the cost of the number of items that day, right? Because you would take the total number of items and you'd multiply by this amount, and that would give you the total cost. Okay, so here is the beginning and ending amounts for the day. So in order to figure out how much was made during that day, we'll just subtract these two. Okay, so so let's set up our equation. So we're going to have 1,058.60 minus 125.50 is equal to 93310. Okay, so we don't have our equation just yet. I just want to kind of figure out what is the total that was made that day. So this is the total made that day. Okay, and now we're going to use this in our equation. So what is our equation? Well, if the cost of the number of items that day is this right here, and this is the total that's made that day, then we're going to set these equal to each other, and then we're going to just solve for x, which would be the total number of items sold that day. So again, on the left we have the cost of the total number of items that day, and we have how much we made that day. So this makes sense that once I have x, I'm going to this equation will be valid. So how do we solve for x? Well, all we have to do is just divide both sides by 1.085. And if you check this, this will be 860. Okay, so again, remember the last step of the strategy is once you solve this, you want to answer the original question. So how many items were sold that day? This is the number of items that are sold that day. So 860 items. Okay. All right, so let's take a look at a geometry problem and see if we can apply this technique to it. So two complementary angles are such that one is 5 times larger than the other, and you want to find the two angles. So complementary angles, after reading your text, or if you remember from geometry, if you've taken that, complementary angles are just angles that sum to 90 degrees. Okay, so the sum is going to be 90 degrees. Okay, so what do we have? Well, we're going to have two angles. Okay, so here's 90 degrees. We have two angles, and one is 5 times larger than the other. So what we could just do there is one of the angles, that's going to be our x. Right, that's going to be our angle x. And the other angle is going to be 5 times that angle. Right? So angle 1, right? If you don't want to draw a picture like this, you could write something like this. So angle 1 is x, and angle 2 is 5 times larger than x, so that means it'll be 5x. And then using this rule of complementary angles, we know that the sum should be 90 degrees, so we're going to get our answer in terms of degrees, but 5x plus x will be equal to 90, which is 6x equals 90. So we'll divide both sides by 6, so x is 15. And again, here we have an answer in terms of x, but we want to translate this in terms of our problem, and we want to find the two angles, right? And we should put them in degrees as well. So that means angle 1 is 15 degrees, and angle 2 is 5 times this amount, so angle 2 is 75 degrees. And again, remember they're complementary, so they should sum to 90, and you could check that real quick, right? I mean, the sum of this is 15 and 75 is 90, so good. Okay, so let's take a look at another geometry problem involving triangles. All right, so the smallest angle in a triangle is half of the largest angle. And the third angle is 15 degrees less than the largest angle. And then you want to find the measure of all three angles. Now, if we read this again, so the smallest angle in a triangle is half of the largest angle. So see, we're given information about the smallest angle in terms of the largest angle. And then the third angle is 15 degrees less than the largest angle. So you see how we were given information in terms of the largest angle? So that is a good quantity to assign a variable to. So let's do that. Let's say x is equal to the largest angle. Right? Now, if you want to draw a picture, you can certainly do that as well. Just be careful though, because we weren't given any general information about this triangle other than that we have three angles. We don't, so just draw a general triangle, but don't make any additional assumptions. So we could label that thing as x, but maybe I'll do both simultaneously. So the smallest angle in a triangle is going to be half of the largest angle. So half x would be the smallest angle. Okay, and then the third angle is going to be 15 degrees less than the largest angle. So x minus 15 will be the third angle. Okay, and if you want to label things over here, you can, but again, you can have these options. All right, so in either situation, just make it clear to me when you're solving a problem like this that the assignments make sense. You know, either write them out or draw a picture, and then from this information, you should be able to come up with an equation. Well, after reading your text, you would see that one general equation that we have for triangles is that the sum of the interior angles sum to 180 degrees. Right? So the sum of interior angles of a triangle is equal to 180 degrees. Okay, and we have three angles here, so here's how we can create an equation, right? We'll just sum these three and set it equal to 180, and we're going to solve that, right? So this would be equal to x plus a half x plus x minus 15. And now we're at a point where we could just kind of solve this using previous strategies that we had. So we'll combine like terms and solve for x. So we have 180 equals x plus a half x plus x. So we have 2.5x, right? So we have 5 halves, or you could write 2.5, it doesn't really matter. And then minus 15, right? So we still have this minus 15 here. Okay, and how do we finish this? Well, we're going to try to solve for x, right? So we'll bring the 15 over here. So let's add that. So we have 195 equals 5 halves x. Okay, now there's a couple ways you could finish this. You could divide both sides by 5 halves, or what you could do is you could multiply. You know, you could sort of do this cross multiplication. You could multiply by 2/5. That's another way. All right, well, whatever. Let's sort of, you can bring the 2 up here, right? So multiply both sides by 2. And we'll have 5x, but then we'll divide both sides by 5, right? So this reduces, and we have x equals this. And after simplifying this, so this will be 78 degrees. Right. So coming back up here, what I was saying is we can multiply by the reciprocal of this, which is what we actually did here, 2/5. But there's many ways to finish the problem, right? So we could divide by 5 halves, and divide by 5 halves is the same thing as multiplying by 2/5. So as long as you get to the correct solution, it's fine by me. Just make sure that you're doing legitimate work. Okay, so we get 78 degrees, and then the measure of all three angles. Now that we have x, we can figure out, well, that's the largest angle, the smallest angle will be half that, and the third angle will be 78 minus 15, right? 63, right? So we could write these out if you want. Let me get a little more space here. Okay, so what do we have? So we have the largest angle is 78 degrees. Smallest angle is half of this, right? So half 78 degrees. Just simplify your answers, right? So that, what would that be? 39 degrees. And then the third angle is going to be 78 degrees minus 15 degrees. So this is 63 degrees. Right? And this will be our answer. And you could check your answer as well. You could sum these and see that it's 180. Okay. So on to some financial examples that are also covered in this section in your text. So Matt has 2 credit cards with a total balance of $12,000. One card charges 10% per year and the other charges 7% per year. And we want to figure out what is the balance on each card if the total interest charged in the first year was $960. Okay, so what do we have here? Well, we essentially have 2 unknowns, right? We want to know how much is on the 10% loan and how much is on 10% on that one credit card, and the other credit card we have some amount, and that credit card charges 7% per year. So we could pretty much just pick one and call that X. So what we could say is X is equal to the amount on card 1 with 10%. But again, we could have started with card 2. The point of this is that once I say that the amount on card 1 is X, how much do we have on the second card? Well, we're told at the beginning that the total balance on the 2 cards is $12,000. So then this means that $12,000 minus X will be the amount on the other card. The other card had 7%. Now, this choice is arbitrary. I could have said X is the amount on card 2 and that this will be the amount on card 1. It's just as you solve the problem in the end, you have to be consistent, and you'll get the same answer at the very, very end. It's just you have to be consistent throughout this problem. You know, from this point on, we know that X is designated as the amount on card 1. Okay, so we know that the $12,000 is split between these 2 cards, and we also know that after the first year, the interest charge was $960. Okay, so how do we get this $960? Well, we're going to take the amount on card 1 and we're going to multiply by 10%, and we're going to take this amount on card 2 and multiply by 7%. Okay, so let me write that out. So the interest on loan on the card 1, so interest on card 1, what is that? Okay, well, that'll be X, right? The amount on card 1 times this percentage. So that'll be multiplied by 0.1, right? So, since that's 10%. Okay, so this is kind of what I was saying here. So the interest on card 1 is this amount. Okay, and how much is on card 2? What's the interest on card 2? Well, we have 12,000 minus X as the amount on card 2. So the interest will be this amount times 7%. So we're going to have 12,000 minus X, and then we're going to multiply by 7%. So 7%, representing that as a decimal, is 0.07, right? So divide by 100 or move the decimal over 2, right? So this is your 7%. Okay, so that's the interest on card 1, interest on card 2, and we will add these together to get the total interest, right? So the total interest charged in the first year was this much, right? So you've just represented the total interest amount. So this sum right here is equal to 960. Okay, so now we have this equation, and we're just going to solve it, right? So let's do that. Okay, so we have 0.1x, oops, okay, plus this, and let's distribute the 0.7, right? So we have 12,000 times 0.07 minus 0.07x is equal to 960. Right, so once you get to this, that's the hard part, right? Coming up with that equation. But once you do that, now we can just use the strategy that we've been using before. So we'll combine like terms. So the 0.1 minus the 0.07 will be 0.03x. And the 12,000 times 0.07, this will be 840 equals 960. And now to isolate this x here, we're just going to subtract 840 from both sides. And so we'll have 0.03x is equal to, so what will this be? 120. And then divide both sides by 0.03. So we have x is equal to 4,000. Okay, so that's x. And what was x? X was the amount on card 1. So to figure out the amount on card 2, we'll just do 12,000 minus that. So card 1, right? Now, keep in mind that we've designated card 1 as the one with 10%. So if you didn't write that somewhere, you know, that card 1 is the one with 10%, down here you could say the card with 10%. Okay, just be clear when you're labeling these things. So card 1 has the 4,000. And card 2 has 12,000 minus this, so that's 8,000. And that's our answer. All right, so let's try to solve another problem like this one. The way that I'm going to solve this second one, you could solve it the same way that I just did the one above, but I'm going to follow sort of a technique that the book uses, and that's to set up this table. And if you find this method a little bit easier to follow, then I would suggest maybe doing that, and you could redo the example above. But you're going to get the same answer. The idea is basically the same. But let's see what happens. Okay, so Travis has a total of 6,000 from 2 auto loans. The total amount of interest charged in the first year is 410. One loan has charges 6% per year and the other charges 8% per year. And how much is on each loan? So see, it's a very similar problem to the credit card problem. You have two interest rates. We know how much was charged in the first year and the total amount that's split between the two loans. So you can solve this problem identically to the way that we did it up above. But let me set up a kind of a table the way that the text does. Okay, so we have 2 loans here. So here are dollars at 6%, and we have dollars at 8%. Okay, so we're just going to set up like a little table here, and we have number of, okay, so the number of dollars at 6%, here is where we could assign our variable, right? Again, this is going to be arbitrary. I can say x is the number of the amount that we have put into this loan, or x could be the amount that we put into this loan, right? So that choice is actually arbitrary, but let's just say it's x here. So x is the amount, the number of dollars at 6%, right? So if that's the case, since the total was 6,000, right, the total between the two loans, And that means you're going to have 6,000 minus X as the total dollars at 8%. And the total, if I were to sum these two together, I'm going to get 6,000. Right? Okay, and then interest on. Okay, so the interest on the dollars at 6%, well, here's the number of dollars at 6%, so how do we calculate the interest? So like we did up above, the interest will be 6% times this. So we'll have to do 0.06 times X, right, to get the interest on the dollars at 6%. And then the interest on this loan was 8%, so we'll do 8% times this amount, right? So 0.08 times 6,000 minus X. Okay, and then what's the total? So the sum of the interest on these loans charged in the first year was given over here as 410. So that's where we'll put the 410. Okay, so this method is kind of nice because it's a little bit more organized, but so feel free to use this setup versus the one up above, but you see that it's actually identical. So your equation is actually given right here. So the right here, we would have that the sum of the interest on the two would be equal to this total. So we would just write that down here. So 0.06x plus 0.08 times 6,000 minus X is equal to 410. All right, and then now at this point you can kind of forget for a second that we're actually solving this this financial problem, and just look at this equation and solve for X. So let's expand. So 0.8 times 6,000. So we could write that out. And then minus 0.08 times X equals 410. And so we have these two like terms. They both have X's in them, so we could subtract their coefficients, right, and simplify this. So 0.06 minus 0.08, we're actually going to get negative 0.02x, and 0.08 times 6,000, that'll be 480 equals 410. So this is looking a little bit better. And then now let's subtract the 480 over. So we're left with 0.02x equals negative 70. And that's good, right? Because we want a positive x, so we have negative negative. So if we divide by 0.02, we have x equals, divide this, we'll have 3,500. So that'll give us the amount in the loan, right? So 3,500 in a loan at 6%. And then the remaining amount, remember the other amount will be 6,000 minus this, so that'll be 2,500. So 2,500 in the loan at 8%. All right.